possibility is there is that there is a probability. क्या होता है, depending upon the sequence of the primer, there is a probability कि primer अपने आप में ही bind कर जाएं. Okay, कि rather than they annealing to the template, they can anneal to themselves also. So this happens, and this results in the formation of certain structures such as the hairpin. As you can see over here, it leads to the formation of the hairpin loops. ये ऐसे मुड़ जाता है क्योंकि ये ऐसे मुड़ के ये स्ट्रक्चर बना देता है. एक ही डीएनए का सीक्वेंस है लेकिन ये आपस में ऐसे मुड़ के ऐसे कॉम्प्लीमेंट्री सीक्वेंस बना देता है, तो उनको हम हेयरपिन लूप बोलते हैं क्योंकि हमारी हेयरपिन भी मुड़ी होती है एक एंड से. या ये ड्राइमर बना देता है, सेल्फ डाइमराइजेशन. डाइमराइजेशन दो तरह की है. वन इज बिटवीन द टू डिफरेंट मॉलिक्यूल्स एंड अदर इज बिटवीन द सिमिलर मॉलिक्यूल्स. तो ये एक मॉलिक्यूल है in 5' to 3' direction. It is the similar same molecule again in the 5' to 3' direction. दोनों उल्टे होते हैं, तो they can bind to each other, resulting in the formation of self dimers. Or there can be dimers between the forward and the reverse primer. They can also form dimers. See, the formation of dimers, whether it is a self dimer or the formation of the dimers between the forward and the reverse primer, as well as hairpin loop, to some extent is okay. Why? Now, these secondary structures generally are formed at low temperature, that is 30 degrees Celsius, that which is normally the room temperature. But whenever the PCR reaction takes place, the very first step is denaturation, which involves the heating of the DNA to 95 degrees Celsius. So at that temperature, the hairpin loops, the self dimers, and the dimers of forward and reverse primers, they get broken up. And as a result, the lowest temperature during the PCR reaction, if we assume it to be the ideal annealing temperature, let us say 60 degrees Celsius or 56 degrees Celsius, the temperature will never go below that. And as a result, if these type of secondary structure are formed at 30 degrees but are not forming at 40 degrees or 50 degrees, then we are on a safer side, because even if they are being formed at lower temperature, they get broken up during the PCR reaction. But if these secondary structures, they do not get broken up at high temperature and are stable even at 50 degrees Celsius or 45 degrees Celsius, then there is a problem. That means the primer is not suitable for that PCR reaction and it will not give you the desired products. So therefore, we have to be very careful when we are designing the primers. Okay, and annealing temperature therefore becomes very important. अगर हमने annealing temperature choose कर लिया in the PCR reaction 30 degree Celsius और 30 degree Celsius पर ये hairpin, self dimer और dimer बन रहे हैं, तो बेटा आपकी reaction नहीं होगी. या आपका डाइमर स्टेबल है टिल 45 डिग्री सेल्सियस और आपने 45 ही एनीलिंग टेम्परेचर रख दिया प्राइमर का, तो प्राइमर तो अवेलेबल ही नहीं है, उसने तो सेकेंडरी स्ट्रक्चर बना रखे हैं. सो देयरफॉर योर रिएक्शन विल नॉट हैपन. So therefore we have to choose the annealing temperature very judiciously, that at what temperature it forms the structures which are secondary in nature and till what temperature they are stable. We have to be very clear about it. Okay, so this is very important. So another important is that this we had already discussed, that primers, they always work in pairs, such as forward and reverse primers. So very important is that there has to be, क्या होता है बेटा, जब प्राइमर है, चाहे फॉरवर्ड प्राइमर है चाहे रिवर्स प्राइमर है, दोनों ही प्राइमर में दे हैव टू बाइंड विद द डीएनए टेम्पलेट मॉलिक्यूल. ओके, अब देयर इज अ पॉसिबिलिटी, एंड व्हाट इज दैट पॉसिबिलिटी? पॉसिबिलिटी ये है कि फॉरवर्ड प्राइमर का अनीलिंग टेम्परेचर मान लीजिए 50 डिग्री सेल्सियस है और रिवर्स प्राइमर का अनीलिंग टेम्परेचर 65 डिग्री सेल्सियस है. Now, if your forward and reverse primer have such a difference in their annealing temperature, then again the PCR reaction is going to suffer. So we have to take care of the individual primer sequence also and primer sequence as a pair. So the two pairs of primers, forward and reverse primer that you have selected for your PCR reaction must be compatible with each other, and their difference in the annealing temperature should not be more than 3 to 4 degrees Celsius. The closer is their annealing temperature, the better the PCR reaction is going to work. Okay, so this is very important. So we can summarize here that our primer should be unique, having a length between 17 to 28 bases. However, the range varies depending upon which type of PCR you are carrying out. Then the GC content should be between 40 to 60%, and we should avoid long AT or GC rich sequences. Even the repetitive sequences should be avoided. Okay. हाँ, this is very important. हमें primer ऐसा बनाना चाहिए in which the GC content, if at all it is higher, it should be towards the 3' end. ठीक है? अगर GC है तो GC should be there towards the GC content should be there towards the 3' end, क्योंकि 3' पे assume करिए it has to bind to the DNA. Okay, so if this is the template DNA and this is the primer, and this will be the 5' to 3' direction. So if this is the 3' direction, then what will happen? ये वाली side आपकी ज़्यादा stable होगी. The more stable it is, the more DNA polymerase can actually hold on to this position and bring out about the process of polymerization. Another important point is the melting temperature of the primer should be between 50 to 65 degrees Celsius. And we should also ensure that the forward and the reverse primer should have a compatible annealing temperature with a variation only between 3 to 4 degrees Celsius. And another important point is that the annealing temperature of the primer should be ideal. Again, between 50 to 65 degrees Celsius, and in such a manner that the secondary structures should be minimum. So hairpin loops, dimers, self-dimers, they should be minimum, or rather they should be avoided during the PCR reactions. Okay. Now, a number of softwares are available nowadays to design the primer. पहले हाथ से बनाना पड़ता था, but nowadays lot of primers are available, such as Primer 3 is very good one, Web Primer, Gene Fisher, Gene Walker, Code Hop, Net Primer, PCR Master Mix Box Titration Calculator, Oligo Calculator, MGH PCA Proteomics. There are so many types of websites and the tools which are available in the public domain, and you can just play with this softwares. Since this part is not in our syllabus, so that is why I am not dealing with the softwares which are involved in primer design. I hope आपको ये समझ आया होगा. So with that, I stop over here, and then in the next lecture we will talk about the next